All right, we're beginning Unit 5, and Unit 5 is rational functions, which has to do with functions that are in the form of a fraction, and these sorts of expressions will be found in the numerators and the denominators of those expressions. And in the process, we'll begin to solve those expressions. But the first thing you have to do is to be able to factor. We've done this before this year. You did it in Algebra 1. But this is again a review of all the types of things you need to do to factor. If you see a binomial like this, look to check to see if it's a difference of squares. Difference means you're going to have a subtraction sign there, which you do. And then you also want to look to see that you have something you can take the square root of as each of your elements, and you do. And so if you remember, when you factor a difference of squares, the first term is the square root of the first original term in the original problem, which is 2x. The second term is the square root of that last term. And in the signs in your factors are 1 is plus and 1 is minus. And what happens then, if you think about this when you multiply it out, 2x times 2x, that's where your 4x squared comes from. Then when you multiply the 2 times the negative 5, you have negative 10x. Here you have positive 10x. That's going to add to be 0. That's why there's no middle term. And the last one is minus 25. And that's the case for all differences of squares. So this is your answer for this difference of squares. Now looking at number 2. You always need to look for greatest common factor if there is one. And there is a 4x we can factor out, which means everything is divided by 4x. So 16x squared divided by 4x is 4x. And then plus 4x divided by 4x is 1. Now sometimes what I notice is y'all forget to write this term. But if you think about it, it has to be there to get, again, it has to multiply to give this original expression. If you don't write it, all you end up with is 16x squared. So be sure that you go ahead and write that 1. That is, it's something you have to have, because when you distribute this 4x, you're going to end up back with your original equation or expression. Okay, looking at this, if there's no coefficient in front right here of this squared term, then you many times can factor mentally. So let's look and see if we can factor this mentally. We have x times x gives me the x squared. Now I need something that will add to be negative 5xy and multiply to be 6 times, you multiply the n terms, so that's negative 6x squared y squared. And we see that a negative 6 and a positive 1 will do that. Now remember, if you have a negative right there, your term, you're going to have one of them is plus and one is minus. And the bigger one will be minus because this term's negative. So that means you're going to have x minus 6 and x plus 1. Negative 6 times 1 gives you negative 6. Negative 6 plus 1 gives you negative 5. Now on this number 4, this looks ugly with that coefficient there, but we notice we can factor out a 7. So the first thing we're going to do is factor out a 7. And that leaves me with x squared plus 4x plus 3. Well, once we have a quadratic term or an x squared expression, we need to see if we can factor it more. Sometimes we can, sometimes we can't. This one we can, so we need to break that down and factor another step. So we have two linear terms where the highest power inside the parentheses is x. And again, factor this mentally if you can. You have x times x. You need two numbers multiplying to 3, adding to be 4. That's going to be 3 and 1. And since this is plus, the signs are the same. Since that's plus, they're both positive. Okay. Now looking at this next one, we can factor out a greatest common factor, which is 8x. Then we're going to have x squared minus 6x plus 9. Okay. Now, again, same process. Signs are the same. They're going to both be negative. Adds to be negative 6, multiplies to be 9. And to me, I think that's going to be 3 and 3. Those will add to be negative 6 and multiply to be positive 9. So we're going to factor this. We have 8x. And then you have x minus 3 times x minus 3. Now, if you want to write this like this, it's appropriate to do that. It's not a problem. Okay? So, let's move on to the next page. Pen back. All right, looking at this one, we run into a little difficulty because there is no greatest common factor. 3, 7, 20, there's nothing that'll divide into all of those. There's no letter variable that they have in common. This coefficient, this 3, makes this a little more difficult to factor, and there's two ways to factor that. You can factor it with the box, and you can factor it by grouping. And I'm going to show you both ways. Okay. We still have to discover the factors that we're going to use. So we have to add to be negative 7. Okay, so we're going to add to be negative 7xy, and we're going to multiply to be, remember, multiply the first and third term, negative 60 x squared y squared, and that's a 60. Okay, so looks like box, but it's a 60. All right, so what could it be? Well, looks to me like that's probably going to be negative 10 and no, that's right. 12 and 5. It's going to be 12 and 5. Took me a minute. Okay, so where's that? So we have negative 12 xy and 5xy are the two factors we're going to use to get that middle term. Those will multiply to be negative 60, add to be negative 7. So the way you use a box, and some of you haven't seen this since Algebra 1, maybe didn't see it then. You put the first term, your 3x squared here, your negative 20y squared here, and in these other diagonals you put your factors that you just discovered. And it doesn't have to be in any particular place. You can put it in either spot. 3x squared, the way to get 3x squared is 3 times 1. 12 is a multiple of 3, so we're going to put 3 there and your x there. 3 times x is 3x squared. All right, now this dimension is 3x, so we have to figure out this dimension. And it has to multiply by 3x to give me negative 12, so it's minus 4y. And here we're looking for the dimensions of this box. We know this is x. We need to figure out this one. And that one must be 5y because multiplied together they give me an area of 5xy. And then multiplying these two, we have our last check. That does give me negative 20y squared. So the factors here, and I'm going to write them down here, are x minus 4y times 3x plus 5y. And that gives me the area of the box when I multiply them together. Now, grouping is the same process, but you don't draw a box. You have 3x squared. Then I list my factors, negative 12xy plus 5xy minus 20y squared. And if you notice, this, I haven't changed the value of my expression because Negative 12 plus 5 is negative 7. I've just split the term, basically, into two. Put parentheses around each one, each set of two, first set of two, second set of two. And then we're going to factor out the greatest common factor. The greatest common factor here is 3x. That leaves me with x minus 4y plus, we're going to have to factor out 5x, and that leaves me, excuse me, not 5x, just 5. Take that x off of there. Factor out 5, and that leaves me with x minus 4y. Now, if I factored out x minus 4y from each, I would be left with two multiplications, or two factors multiplied together. So we have x minus 4y times my other factor is what's left here after I factor out the x minus 4y, which is 3x plus 5. And if you notice, we got the same answer both ways. And so you can use whichever one you prefer. I use grouping. Some of you may prefer to use the box method. Now in these last three examples, we have four factors evident. When you have that, just go ahead and group them. Factor out your greatest common factor. In this case, it's 8x squared. And that's going to leave me 3x plus 1. And here, my greatest common factor is 4. And that's going to leave me 3x plus 1. So my two factors are 8x squared plus 4 times 3x plus 1. Now you could have factored out a 4 to start with, because we can see we can factor out a 4 here. So we're going to go ahead and factor out that 4. And that leaves me with 2x squared plus 1. And then times 3x plus 1. And that would be the complete factorization of this polynomial. You could have factored out the 4 first and then factored your what was left, grouped what was left, or done this and factored the 4 out at the end. Look for a greatest common factor. There is not one, so we're going to just group. Now, when there's a negative here, I would change it to plus a negative and then group the negative in with the parentheses. I think that saves some confusion. So, the greatest common factor is going to be 6x, I believe, and that's going to leave me 5x plus 6x squared. It's going to leave me 5x plus 3. Then here we can factor out a negative 1, which leaves me 5x plus 3. So my factors, my answer is going to be 6x squared minus 1 times 5x plus 3. Okay. Now, look for a difference of squares if you still have a quadratic term, a term with an x squared. Try to get things down to linear terms, linear factors. But I can't factor this. Up here I couldn't factor this anymore. So my answer has to stay like this. But if you can factor it further, you need to do that. Looking at number 9, there's no greatest common factor, so we're going to change this again to a plus negative and put that negative in with the 18. First term, we're going to factor out an x squared, which leaves me with 2x minus 1. And here we're going to factor out a negative 9, so that will leave me 2x, it should have been a plus 1. Okay. So my two factors here are x squared minus 9 times 2x plus 1. Then look at your quadratic term and say, can I factor that even more And this turns out, if you look closely, is a difference of squares. So this x squared minus 9 will factor more as x minus 3 times x plus 3, and then still times 2x plus 1. So we've broken this one down to 3 linear terms. The number of linear terms will never be more than your highest exponent on your x. So x cubed means that we would have no more than 3 linear terms, and that's as far as we can go. It's factoring. Okay, that's the end of that. We'll start differences in sum of cubes next time.